Okay, let's look at this quadratic equation. Solve x squared minus 6x minus 3 equals to 0. And we won't be able to solve by factoring. You can try it, but it won't work. And we will not be able to solve by the square root method because we can't get a variable term squared equal to a constant number. And so I'm going to show you how to solve this by completing the square. I want you to see this technique. And because you're going to use completing the square as a technique in different kinds of problems later in this course, and also if you take our trigonometry course, you'll see it again. So it's good to see completing the square. And but I wanted to start off with one that was fairly easy, in order so it'd be a little easier to follow. All right, so here's how it works. I'm going to, first of all, completing the square, let me write that term up there. Completing the square. I'll explain what that means a little bit later, where it got that name. But in completing the square, your first order of business is to make sure your leading coefficient, that's the number in front of x squared, your leading coefficient is 1. And it is. And so once that's done, then, and if it wasn't, we would have to divide everything by that number and usually create fractions. But now that that's okay, then our next step is to transfer the constant term to the right side. And so now watch how I write this. It's going to be x squared minus 6x, I'm going to put a space here, equals to positive 3. Alright, now that might seem a little counterintuitive because normally we deal with quadratic equations written in descending powers equal to 0. Our next step is to take half of this number. And so now half of negative 6 is negative 3. And I'm going to, and that 3 has nothing to do with that 3. It came from half of this coefficient. And what am I going to do with it? I'm going to square that negative 3 and add it to both sides of the equation. Alright, now you'll be using this technique in a different context later on, and so it's another reason why I like to cover it here. You'll appreciate it later. But this was kind of an odd step here, to take half of this number, square it, add it to both sides. I hope you see that adding to both sides makes sense because, to keep the equation in balance, I have to add the same number to both sides. But other than that, why do I take half and square it? Well, you'll see in a minute what happens here. So let's go ahead and simplify this out. This is x squared minus 6x plus 9 equals to 3 plus 9. And on the right side, this is going to end up being 12, isn't it? Now, when you look at x squared minus 6x plus 9, it turns out that factors. And matter of fact, it factors as x minus 3 times x minus 3. And both factors are identical, so I could write them as a perfect square. Alright, so the completing the square technique involves making an adjustment to a quadratic in such a way that you end up with a perfect square binomial. So you complete the square. That's where it got its name. And it's a clever technique. It works every time because it fits into a pattern that always works. And what good is it? Well, now I can use the square root method that we just discussed because I have a variable term squared equal to a number. So this whole technique revolves around forcing this issue to this situation where we can now take the square root of both sides, and don't forget the plus or minus symbol there. And this gives me x minus 3 on the left side equals to plus or minus the square root of 12. So there we go, and we're almost done with it, but that's the idea of completing the square, is that it brings you to a point where you can use that square root method. All right, now let's go ahead and finish the problem. And we should simplify the square root of 12. That would be the square root of 4 times the square root of 3. So, and I need to make a little room here, so I'm going to erase up here. So I have x minus 3 equals to plus or minus, and this is going to be 2. Notice how I simplified this. I hope you've done this before. Simplifying a square root when you can do it means factoring into a perfect square times a non-perfect square. Square root of 4 is 2, so I end up with plus or minus 2 times the square root of 3. And finally, to finish the problem, I need to add 3 to both sides. And so x equals to 3 plus or minus 2 times the square root of 3. So I have two answers to this problem, and this is written in the symbolic form right here. But there are two answers, 3 plus 2 times the square root of 3 and 3 minus 2 times the square root of 3 would be the two different answers. So there we go. That's completing the square. Now, what are we going to do with that? Well, I'm not going to expect you to learn the completing the square technique for solving quadratic equations. You know, you'll need to learn it a little bit later for other things that we use it for. But the quadratic formula is a little faster to learn. And now, when I was in high school, we learned completing the square. We had a whole week. We just drilled that stuff for a week. And so I got very fast at completing the square. And because we drilled it so much. And now that was back in the early 70s when there were no calculators and people had to learn, you know, all kinds of approximation and solving techniques to solve various kinds of math problems. And we had time to do that. In here we don't have time to drill completing the square for a week. So I'm going to move on and now derive the quadratic formula in the next video.